Okay, I think I can resume this event. And next speaker is, of course, the famous Christian Adele, who also organized most of this. So let's please congratulate him on this wonderful event. That's what I wanted, but I didn't want to ask for it. Christian is going to speak a bit shorter because we have to catch up with the time. Yeah?
We're going to make it a lightning talk. I think that you will have enough of me with 15 minutes. The presentation is going to be, actually, as you can see, we are only one today. It's me, Christian. But this is a presentation that is a shared effort. It's a shared effort with a group. Maybe you know Wim from Nokia, Damian from OpenSmill. They have been working on the networking industry for a while. And this presentation, called the Network Automation Map, tries to solve something that modern networks need to solve. So modern networks, it's hard to think that they run without automation. At least the kind of networks that all this AI boom, all these big companies running things at scale, clouds, they do everything with automation. But that's only a subset of all the networks that are around. And not everyone understands the same what automation looks like for the networks. And this is what we try to solve together, because for an organization, it's kind of I'm not going to say a mess, but it's complex. You get a lot of tools, a lot of different solutions. All of them solve a problem. But at the end of the day, when you have to solve your own organization problem, you don't know how to connect these tools, and you get lost in the details, and you just go for one tool that solves part of the problem, but then there is a problem that is uncovered. So how you can make something that is easier for yourself to understand and evolve. And the way to do that, it's trying to not build everything from scratch. For sure, you have a company of 1,000 engineers. You can build your own network automation stack from scratch. No problem. Maybe not efficient, but it's doable. But it's solved. There are a lot of companies that are doing automation. So there are data models, there are tooling. Just try to reuse these things. However, what we have found, and actually have been working as a consultant for, I'm going to say 5 years now, not my current job, but I saw how many companies were struggling on the implementation of this automation, because you find a lot of problems that, failures is the way to learn, but if you can reduce them, it's always better. And finally, it's hard because there is not a reference or I'm going to say an easy to understand reference to put all this automation in place. That's what we will try to solve here. And to make that happen, in the Network Automation Forum community, who knows about the Network Automation Forum? Yeah, it's quite popular. It's an initiative, I'm going to say, that is running 2 big conferences in the US and Europe. Next one coming here in Munich in June. And it's a group of vendors, community practitioners that they try to understand how to automate solutions. And we come together. Actually, this table is from a photo that I was around, maybe this one, I don't know, it's generated by AI. And we try to solve the problem, how we can make automation easier for people to adopt. And that was the result. I was speaking Catalan in my own here, but I mean, we were not able to understand what we are saying. And not because we don't have a lot of good background and good ideas. It was because we were not sharing the same words. And maybe we were using the same words, but with different meanings. And that's even worse, because then you start arguing, saying the same, and you don't fully understand. And the conclusion was that, we have to try to agree on some concepts, general concepts, very simple, I'm going to say, at high level, that all of us can understand what's the boundaries, the goals for that. And that was the goal of this Network Automation Forum. We came together in different meetings, too much talking, and at the end someone had to take the lead and get into not a reference architecture. We are not here at the ITF to generate an RFC like Paolo or Camilo or people are doing. No, we want to just make something easy, like a shared vocabulary, shared responsibilities. And this is what we come up with, this fantastic Google drawing that I built. So it was different blocks. And these blocks that maybe you can now start thinking, oh, that looks yet again as an architecture that I don't really understand, which tool belongs to this other tool. Think about this like a container of responsibilities. What's the responsibility of which one of these things? And in order to understand that, we're going to make it happen with an example. I think that is better. The goal of this framework, as I said, is just define blocks. Not go deep onto the details, but just define the boundaries, the concepts, and make it as a living protocol. So we did a first try. We did a first version. I don't know if it's version 0, version 1, whatever it is. But it's not complete. It was the outcome of an effort of, I'm going to say, between 5, 10 people. And we are getting more and more inputs. And this presentation has been done 3-4 weeks ago at Nanoc in the US. It's going to be repeated in AutoCon, in RIPE, many meetings, just to share these ideas, to get more people talking the same vocabulary, because that's what we are looking for. And it should be working well for beginners and for experts, just because we try to get a common play for everyone. At the end of this, as I said before, on that architecture, there is the presentation layer, the intent, the executor, the orchestration, collector, observability, words that maybe don't tell you too much, but I'm sure that you are familiar with in terms of a specific product. Because at the end, there are products. So what we have to do is try to get the same way that you have brands for a car, but at the end of the day, a car has batteries, has a chassis, has brakes, suspension. There are some common standard things that everyone implements the best that they can, but everyone understands what you are building. And the target audience, as you can imagine, it's for the people building the automation, but also for the people using the automation. Because sometimes I have seen many projects fail because you built a product, but you're not the one automating or using the product. And if you don't build and you don't make this product transparent enough, who has to use that doesn't trust it. And if you don't trust it, you don't use it. And it's a failure. So trying to get something that everyone can get together to understand is the goal of this network of automation reference framework. And you may be wondering, so where are my tools? Where is the AVD that Xavi presented before, or the NetLab that Ivan presented before? All these tools are still there. We just want to give you a way to map them. For example, a tool can map to different parts of this architecture. Completely, partially, usually many products tend to spread and do everything. But at the end of the day, if you look deep, every product has a specific focus. Okay? Not everything works for everything. If we do this exercise on some, I'm going to say, popular observability tools, just to monitor the network, the main layers for this are the collection, the component that I have omitted on the presentation that is getting the information from the network, processing the information, normalizing, storing, that is the observability part, and finally, that information you want to present to the user in a dashboard or into a CLI, whatever you want. So these are the components of the architecture. What we want the community, the vendors, to do is something like this. GNMIC, who knows GNMIC? GNMIC is a small product focused on GNMI to collect information. Doesn't give you a UI, for sure it has a very simple CLI, but we have omitted that presentation, but does nothing about storing the data, just collecting. So GNMIC is a collector. Prometheus, very popular time series database. Prometheus is not, can collect in some component of the architecture, but the core of Prometheus is observability, is storing. The presentation in Prometheus, you can go to the UI and you get something, but it's not the core thing of Prometheus. If you want to visualize something in Prometheus, what comes to your mind? Grafana. So Grafana is a presentation tool. Grafana doesn't focus on storing information, just focusing on that. But at the same time, you can look for different products like SusieQ, Kentic, that they try to cover all the spread, all the ecosystem, and that's totally fair. So these are tools that I try to collect information, not everything, but a lot of things, persist the information, normalize it, and actually gives you a UI to productionize it. And this is only on some part of the architecture. We are talking about collection, observability, and presentation. We are missing the orchestration. We are missing here the executor. We are missing the intent, because these tools don't pretend to do everything. But does it sound reasonable for you? It's just a framework for you to think together the same. And where you should start? So that's one important question when I came into any network automation project. You don't need to cover everything on the first day. That's almost impossible, and it's a recipe for failure because it's too much. Usually when you get into network automation, first thing will be maybe provision some VLANs, the small configuration snippets. Sometimes it's just to check the state of something at scale. The point here is that having this reference architecture, that again is more like a structure for you, gives you a mental model to say, okay, now what I want to do is to start changing my network. I want to automate at scale. And the question that you should do first is, okay, I'm going to automate what? What is the goal? What I'm trying to automate here? So you need some data, some reference. That's in the architecture that I pass very fast. It's the intent. It's the final decision. Maybe you know it more about source of truth. It's another wording that we decided to skip because many people understand it wrong as a single unity. And again, these blocks, you should not imagine that a block is a single product. When we talk about the intent block, or source of truth, in other words, I use both interchangeably, it's not a product. In reality, what you have is a database, another spreadsheet, a YAML file, and all these things together have to make sense for your network. Because it's a block, it's a container of things together. And the order, again, is up to you. You can start first implementing the observability part, the collection, because you don't want to touch a network, but you want to see what's going on. Or maybe you want just directly try to automate tasks. And eventually, when things get complicated, is when you try to close the loop via orchestration and try to concatenate multiple things together. So to close this, I'm going to go to the example now. This is the group that were the ones initially working on this project. I guess that you didn't see the second time that appears in this conference, and he's not here. So I have to ping him about that. So yeah, this is a group that have been working on that. And I want to give you, here is the presentation is longer. I can go into every one of these blocks, focusing. I'm going to skip all that stuff. All this information with the traditional must, should, may, it's in the document. You can check what are the things that every block should be doing. But the easier way for me is to go into an example. Practical example. And very simple here. Again, the same architecture. You have the presentation for the users on the top, users and external APIs that integrate with the intent, defining what do you want to achieve on the network, executing it that is talking with the network infrastructure. Then you collect the result. Finally, you process it, store, whatever. And if everything goes well, the workflow will just orchestrate all these things working together and presenting the result back to the user. So with a concrete use case, let's roll out a subnet across 50 sites. Where you should always start? Someone in the presentation layer have to bring some information into the intent. So this is the subnet, this is the VLAN, this is all the information that defines the intent. In a very abstract level, don't think about commands. It's an abstraction model of data, up to you, whatever you prefer. You can use something that is already available in the industry or invent your own data model. That's totally possible. Once something changes on the intent, you have to trigger. You have to start doing things. So you trigger a workflow. A workflow here, an orchestrator could be something as simple as an Ansible playbook, one task after the other, or something more complex like Intential, or some tools like build really complex orchestration systems. When this is in place and a task has to be executed, you just call your Ansible playbook, your Terraform plan, your Python script in order to connect with your network infrastructure. Do the change, execute it. And when you do the change, then the collector gets the result of this operation, see what's the state, brings the information into the observability platform. The workflow orchestrators then compares, okay, that's what I'm collecting, that's the information, that's what I expected. Are we okay? Can we move into the next step? If so, then you just present the result to the user, or if not, you just stop, roll back, or whatever. And something that you should not forget, and that's the end, this applies to testing on your lab environment. You should never do this first in production. Do it on your first in the lab that you may have using NetLab or wherever, or in a small site. And then you can run all these things in every kind of network. Network infrastructure is not only physical boxes. It's also cloud services or wherever defines your network. This is a pretty simple example that just tries to cover all the different steps. Everyone, as I said here, there are no tools. Just put the tool that you prefer. Sometimes you will find many tools here, because maybe you are working with a multi-vendor, so you have different executors per different platforms. You can have here many different network infrastructure. And again, every block can be as complex as you imagine. Additional resources, as you can see by the books at the end, I like writing. And I am working on a new project called Designing Network Automation. That is a free book that I'm writing, completely open for everyone to take it. And some chapters have already been published. I think that I'm working now on the 5th one, but it's up to you just to check it. And Claudia De Luna is also working on this cool tool that, given some questions, give you what these tools reference into the architecture that you are building. This is actually, everything is open source. As a summary, don't want to make it long, but that's not a standard. We are not pretending to be a standard. It's just as a community effort, we try to agree on the lexicon, what are the wording, the concepts, and how these things work together. The final goal would be that the vendors use the same lexicon in order to explain the same concepts. So when, for example, when Xavi was presenting the AVD before, he could use that architecture and say, okay, AVD gives you the YAMLs belong to the intent. The different scripts that do that stuff are the executor. The network is Arista network that could be running in the virtual boxes or in the whatever. So that's what we are trying to achieve, that the vendor and the practitioners and all the community can speak the same language. That's all. Thank you very much. Quick question. I don't want to take too much time from the next speaker. Any question from the audience? No? Good? Perfect. Next.
Next, we have Akira-san talking about QoS.
It's ready. Do you use this or HDMI?
HDMI.
Take your time. Yeah. There's plenty of
Is my mic? Is my mic? I think I'll hold it with my hand. Yes. So, yes, I think. This is fine. This is fine. Yeah. So today I'm going to talk about QoS real-time packet handling. Most use cases currently you see is MS Teams, Zoom, Google Hangout, but also remote control, like a drone or something. It's this kind of the technique is used. And that's how I started to enter the IETF activity. So that's my talk today. So before, I need to explain who about myself. And then, how I became into the computers, because, everybody have a different background. And then I started to have went to MS degree program in Columbia University in New York. And then I was participating in the real-time application project there. And then, this is the main topic of today. And yes, at the end is what I do at IETF. So before that, Yes, I moved from Tokyo to Barcelona 2024. Yeah, good food, good weather, good people. And honestly, I was in New York for 3 years, and before that, when I was until 6 years old, I was about every year I was between Japan and U.S. So about 3 years until 6 years old was I was in U.S. So I thought Barcelona living is a little more closer to U.S., but it was end up much closer to Tokyo. Um, so yes, the people who use how you use energy. United States, you have a central heating, home, and everything. In Japan, and here you have each room have a different heating and etc. And in the U.S., you have everybody holding a mug cup and moving around all over in the office. Yeah, it doesn't happen here. And yeah, use umbrella. And I really was surprised that in the winter in Japan, you have in the stand they sell the sweet potatoes and yeah, those stuff. And I don't know now, but yeah, in Japan it used to be the traditional home used to be optimized for the hot summer, which means deadly cold in the winter. And yeah, and many of the sizes much similar to Japan's size, even the sink of the toilet. So now I'm working at the OpenChip. So the company OpenChip is a private company, but the development money is coming from EU. And who made the OpenChip is that this is the stock shareholder percentage. Barcelona Supercomputer Center holds 46%, and GTD holds 54%, which make these kind of the product. And it's making a HPC and AI accelerator, which is similar look like NVIDIA accelerator. And it's not just starting from designing the, yes, this is need a little bit of explanation. What the hell means full stack means. Developing from a semiconductor, developing a PCB, and then need to have a CUDA equivalent SDK, otherwise customer won't able to use it. Okay. And yes, basically it's a Europe company. Of course, the headquarters is Barcelona, but basically it's Europe company, France, Italy. Many of the semiconductor hardware engineers from Italy, Poland, Germany, Belgium, Ireland. Belgium have many of the AI engineer, and Ireland have many, yeah, variety of expertise. And this is how I started to explain how I get into the computers. So I grew up in Japan, but my father was a mechanical engineer, which many people do not know, but IBM used to make a typewriter, which has nothing to do with the computer. And my father was typewriter mechanical engineer, ended up developing automatic cash, what do you say, ATM machine? Yes, yes. That's a huge, complex mechanical beast because there's a place you insert the bank book and then flip the pages and print it and spit out, and also the counting the money and then the coins and then spit out. It's a huge mechanical beast, but just a regular employee salaryman, so not a rich or regular middle class family I grew up. So for the 1980s and for typical Japanese family, have a chance to touch the computer was really difficult because the Apple II was sold, but if you buy Apple II with this display with a floppy disk set, the price was about the same price of the Suzuki Alto was the cheapest car in Japan. So yeah, started to program with the calculator. Does anybody still remember the calculator had a programming feature? Yeah, and then and this first time I was able to. This is my father's. I said I borrowed it, and then I still have it, but that's not fun. And this is the one I bought it. I really was happy when I had my first multimeter. I don't think I hold it and slip together, but I was really happy. And this is the around 1981 or something, the microcomputer magazine started to sell in Japan. And when I saw that, I was really wanted to, first I just wanted to play games, but then I just wanted to know how those, what program or how that the computer works. So when I entered the high school, I bought 3 digital technology book because most of the bookstore in my town did not have any computer books or magazines. So, and yeah, this is the first schematic I wrote. This is the one after I debugging. It took 2 months to debug this one. Yeah. And if you're going to want to learn digital logic, don't try to scratch to make a circuit by yourself. Please copy, yeah.
You must be at least 42 or 43.
Little more. But if you're going to do it, just start from copying the circuit well known to be work. You don't start from designing from scratch. It took me 2 months to debug, and then the second version is much better with the same feature. And yeah, I had to write the assembler. And in those days, assembler itself was, you have to purchase, but if you're high school, you can't buy the price, don't have the money, so you hand assembling with the CPU instruction. Yeah, and then this is something I was doing in university. Well, it's in, yeah, so started from here, and then, yes, if you study computer science in reasonable university, this is the book, Hennessy and Patterson's computer architecture book. That's a thick, heavy book. Yeah, it was a very good one. And then I ran out of money, so I started to work on the project called Cinema, which was the first application, which was audio and video conference with a text chat feature plus sharing the screen. So it's pretty much the feature-wise, pretty much the same what the Zoom could do. And this was in 2001 to 3. But then the problem was the audio, video, the quality wasn't good. So I end up all the way optimizing it. And these are the numbers I was constantly monitoring. What's the RTP, RTCP packets, and etc. And how much? Yeah, I still have time. But the problem is, you really need, when you try to optimize or you need audio, video, or real-time buffering programming, you really need constant network emulator for generating always the same packet loss rate, or same delay time, or same out of order rate, or same rate of the jitter. Yeah, because the packet send even 20 millisecond interval, the receiver don't always arrive 20 millisecond interval. So you really need to those artificially generate. And that time there was nothing, so I had started creating from this kind of tool called UDPL. It's still good. The README itself is on the public network, but the source code link is broken here. It used to be linked to the university's Git CVS repository. Yes, and then constant monitoring the QoS parameter, it's not that easy, so you need a little bit of helper program. What I called was RTP QoS. So it's measuring round trip time, rate of the actual arrival time from the expected arrival. So it's a jitter, or what do you call it? Yes, rate of jitter, and yes, and packet loss. This is on top of the audio video transmitted. So you inject the constant packet loss, jitter, reorder rate, and you monitor on the both sides, the sender and receiver, how much of the audio or video was recovered. And from here, this is the 3 pages, the most important one. I never explained it, or I never saw it's written in documentation. I'm not sure why nobody who have done this, like I'm pretty sure if I use Google Meet, I'm pretty sure they know all this knowledge, but I never saw it's written somewhere. So yeah, so these are the technique you need to know to have a good quality of the real-time transmission on if it's on which requires a round-the-trip packet. So like video conference or call application, or like a remote control like a drone or something. So you need to know not all the data have to be bit accurately to transmit from the sender to receiver. For example, audio, people is okay if some 5 milliseconds or something, the packet is dropped, but you just a little bit have a low voice, a little bit of low quality or low volume or something. People typically don't realize it. So you don't need to always ask the sender to resend the packet. And the video, people really don't care. If you see a green block noise, people don't care. So, it's really difficult to make this kind of application if you try to run it on TCP, which you cannot have a control. That's why Google started to do with quick implementation at a certain IETF. And that's not all. Preventing buffer overflow or buffer underrun, which just means if the sender keeps sending a faster data rate, then this should be receiver, but the receiver will be keep overflowing by becoming a full and not able to inject the incoming buffer data to the buffer before the data is send it to the hardware codec or audio codec. So, and the underrun is if the bit rate of the sender is slower than the player on the receiver, then always the buffer will be like keep having an empty buffer and not able to send the data to the audio or video. So you keep hearing glitching noise. So this is this is the most difficult portion to prevent. But start from the easy one. So, yeah, okay. Packet loss. Packet loss and arriving reorder is the easy one to recover. So you have a buffer, and every single packet has a sequence number. So if the sequence number is, you see the number skipping, could be a packet loss, or could be a reordering, or could be just one of the packets just happen to be very slow, and you just cannot wait. But yeah, that's how it is. So what you do when the packet arriving too late, or packet might be lost, and when you're having a buffer and you need to send the data to the codec or and the hardware, and the video insert some empty data, that's perfectly fine. It will make a green block noise, but nobody cares. I mean, most of the people don't care. Audio is much difficult. Do not just. I saw so many implementations. If the packet doesn't come, shorten the data and send it. No, you do need to compensate the same exact data which you're missing, and with some little bit of dummy audio. So what you do is you check the next packet, and see the audio level and make a little bit of a dummy data, which is slightly go up from the silent to up. Otherwise, if you input the zero volume audio, people hear as a uncomfortable glitch. So you need some smoothing data, the dummy data. And the packet arriving reorder, if you have a buffer, it's no problem. You insert in the certain place, which should be appropriate. And so this is the buffer is the way if the packet sender is sending in 20 millisecond interval, but receiver is receiving 25 milliseconds, 26 milliseconds, 10 milliseconds or something like that. It's perfect. We will be able to compensate in the buffer, but you need to be careful. You cannot make a buffer infinitely large, because if the buffer is larger than for the audio usage, if it's more than 1 second, people will think you're using a phone in 1980s for the international call. Hello, 1, 2, 3. Hello, come back. Yeah. So you want the small size buffer as possible. So you really you need to do it with like 200 milliseconds. With my experience, to 500 milliseconds, people started to feel a little bit slow. I'm sorry, I'm not putting all those numbers here because for a variety of reasons. And also, the packet could corrupt in the internet. Many people don't know, but it does. And you do not need to ask the sender to resend, because this audio, video, human is okay with not to be the 100% the data is accurate what was sent from the sender. Now, this is the most difficult portion. So I said about the buffer underrun and buffer overflow, which real cause is happening because this side and this side, when doing a video call for about 10 minutes, and start to have a large glitch, is because most of the device, IoT, PC, they do not have an accurate clock source. Of course, to compensate that, like a 3G network with the equipment on the cell phone, they do use GPS clock. That's fine, but every single laptop have a GPS clock source? No, it's not doable. So you need to do it without it accurate clock source. Then what you could do is inside RTP and RTCP header and data, you have a NTP timestamp for the period, certain time, and then if you receive the next RTCP packet, you have another NTP timestamp, and then you could see how many data the sender have sent. It means you could use NTP time as a wall clock timer, so you could calibrate that. On my side, it says 5 minutes, but the sender side have sent 5 minutes and NTP timestamp, but the data itself, the byte, if you count the byte the number, it's about 5 and 3 seconds, 5 minutes and 3 seconds, or 4 minutes and 55 seconds or something. It means the sender is, the clock is faster or slower. Then you need to calibrate the constantly monitoring and then adjust the speed of how fast you send the data to the hardware. So typically audio, CD is 44.1 kilohertz. Most of the historical telephone, IP phone, we used to be 8K or something, but 8K BPS or something, sampling. But it depends on the hardware, but if you see the sender is sending to the clock source of the sender is faster than the receiver, then the receiver need to react that you need to slightly increase the speed of the play speed. which is some of the hardware is not able to change the frequency, then you need to slightly cut off the data. And if the hardware is not able to change the frequency, but you still need to do the opposite to increase the data size because the sender is clock source is slower, then you need to implement a little bit of duplicated data, like a 0.1, not 0. Like if it's 5 milliseconds data duplicating embedded in the audio and video data. No, people don't care. They just won't realize it. So just do it, and then it works fine. Yes. And this slide I wrote somewhere that, yeah, I think it's all right. Yeah, I think that's pretty much real handling it's required in this kind of implementation. So you need, and if you really need to optimize all this program by keep changing the packet loss rate, round the trip time, because some of the optimization only works if the round the trip time is close and short. If you have the round trip time a little bit longer, some of the optimization you implement it started to have problems. So you need to keep changing and then do the optimization, redoing, and play and see the log of the RTP QoS what I made, and then I need to optimize here and here and this. And yes, and this is this kind of the technology? Is it really academic? No, it's not. So if you try to teach them in university class, it's engineering, but it's not theory or anything. It's just kind of engineering hack or something. But it is important because otherwise people won't able to do all the YouTube. YouTube is not that difficult because you're just receiving it. But if you something you need to send the data and receive the data in a short time, but need to be work reasonably. Yes. Okay. So then I end up somewhere from 2018, 19-ish. When I was working on art cinema project, I was just implementer. But somewhere for 2019, I started to be an implementer of the TP protocol. So mostly the documentation not written by me or other people, but the implementation mostly was done by me and David Weider from Dave Toller from Microsoft. And yes, AIST was the organization which used to be government R&D division and part of the Ministry of Economy. And yes, these are the implementation description. And yeah, this is something, I haven't brought this to Barcelona, but yeah, that's something I used to do because of the high school experience. And this is this is when I was working at Sony Computer Entertainment, which was the first product in the market required a GPU type of programming, like a CUDA or something. That's why I have a job at OpenChip right now. So this is the reason. And this is the prototype when the first Linux booted. It had a two general CPU, and 1, 2, 3, 4, 5, 6 was the GPU programming core. Yes. And I do not know why, but when I was working there, I was told to make a pose and some of the background, and then for the employee introduction, employee picture, and end up showing here when the first cell CPUs bring up board is shown on the back. But yeah, when the semiconductor comes from the foundry, it is the big, huge PCB. And this is something when I was working on Linaro. Linaro is the company which equivalent to Intel Open Source Technology Center, but was not built inside ARM company. It was built externally as a Linaro. And many of the people here I met when I was working at Sony Computer Entertainment, because the many people who was working on the MIPS and PowerPC was shifting to Intel or ARM. So, yes. Yeah, that's about it. Okay. I think my talk was different from usual topic here, but I know it's yeah. Is there any question? Yes, please.
So when you adjust for the clock speed difference, so if one side starts to NTP sync, there is
Yes,
a period
yes,
when
yes,
the
yes,
clock
that
drifts.
happens.
Did you
Yes.
have to do some adjustments?
Yes, I did. Yes, yeah, I didn't write it down, but that happens. Sometimes the sender, the time skips, go back or go forward. Yes, that's a nightmare, but that happens. And most of the time, luckily that the sender do not do the NTP sync every 5 minutes or something, like a few times in a day or something. So it's typically you only have to worry about one occasion. Yes. But easier one is have atomic IC or something in the both sides. It's much easier. And that's how the network, many of the 3G, 4G network equipment on the base station is doing. But yeah. But many of the something like small device with 4 propeller flowing, no, you can't use those expensively. Yes. So.
Thank you, Akira.
Yes.
Thank you.
Thank you.
Thank you very much.
So next we have Asier from Cisco talking about NetBCN with LLMs.
MCP?
MCP and network as a code.
Yes. Internet.
Tranquila.
Okay. So this is a new keyword, MCP, Model Context Protocol. Is everyone familiar with it? Yes? No? Okay. So this will be one of the things that I will include on my demo. Thanks for connecting the cable. So the title of my session, it is Network Vibe Operations. And it is about basically using natural language to operate networks in the same way as we could be saying, hey Siri, do you mind switching the lights off in the front of the room so that we can see better the slides? And maybe Siri will not work, but hopefully the demo will. I work for Cisco with a focus on automation and data center infrastructure. And before I run the demo, I will go through a very quick introduction where I talk, if this works, let me enable it, yeah? To talk about the future of networks. I think the goal of networking and the reason why we are here is because one day we expect to contribute to autonomous networking, right? And when talking about autonomous networks, I like to compare it with autonomous driving or cars. How many of you did you see autonomous cars in Barcelona today when coming to the event? None, right? And we are already talking about autonomous cars for 20 years, if not more. And what we are seeing is that there are a lot of innovations which are contributing or advancing in the journey to autonomous driving. So we see the park distance control systems, lane centering systems. I even had a car where you could take your hands off from the steering wheel and would drive for maybe 20, 30 seconds. So this is a reality, but we're still far from the day where you can sit in the car and say, hey, can you take me to El Poblano because I need to deliver a presentation. We are going to see it one day, but we're still not there. And with networks, it is the same. our aim, our goal is to have autonomous networks. Xavi from Palo Alto was talking about autonomy, self-healing networks or security systems. And what we see today is that we are progressing, we are making innovations, we are working on automation, on standards that enable us to progress, to advance in that journey towards autonomous networking. And there are three components that contribute to an autonomous network, right? There is observability and assurance. You cannot improve what you do not see. So we need to have visibility insights about what is happening in the network. Anomaly detection, that was the conversation in our first session today. Then you need to automate. You need to codify your infrastructure. You need to have a digital implementation and operation of the infrastructure in order to be autonomous. And what we have in the middle, it is intelligent decisions. We are going to use machine learning. We are going to use generative AI to craft wisdom using AI from what we are seeing in the observability tools. And then we are going to take decisions, and we are going to apply them to the network using automation. And when we have the three pillars, then we are going to be in the path, in the good path to an AI-powered autonomous network. And I hope this helps you understand the relevance of automation. You were talking about automation. Why do we want automation? Because it is helping us to be more autonomous, right? Our vision at Cisco, it is to implement, develop, and that's what we have done, and we continue to do, a data model-centric approach to the life cycle of the networks, right? If we look into the different architectures from data center, from WAN, securities, Meraki, and campus, and so on, what we are doing it is to model all these network architectures, and then we use tooling. We talk a lot about Ansible. You were the first one to mention Terraform today. I was very happy to hear that. So we use these tools to convert the data model into network configurations. But not only that, it's not only about configuration. It is also about capturing requirements, designing, implementing, so delivering the full life cycle of a network based on a data model, right? And hopefully it will be a standard. So when customers ask us, look, this is your data model, but this other vendor is presenting another data model. Can we standardize? So hopefully initiatives like the one you are contributing to will take us in that direction. Now, the demo I will be conducting very soon, it is about how automation it is enabling AI-assisted operations. So in the demo, what I will have is a data center network based on an ACI network controller. We have a REST API, we have a Terraform provider, we have network as code modules, and on top of it, a YAML file which defines my intent. So we are going to see a YAML file defining what I want to have in the network, and then I will be interacting with it using audio. And we are going to see how network operation, it is becoming as easy as having a conversation thanks to the fact that we have organized our network data in a data model that the AI systems can interact with. So let me go now to Visual Studio Code. Well, first, I have here, let me see if this works, yeah. Put here. This is a network controller for a data center network, where you can see that we have a marketplace application with three networks, a web layer, an application layer, and a database layer. And this is just the configuration that we have deployed using Terraform. In this case, this is my YAML file. This is the definition of my intent configuration. Can you read the screen from this? Okay. So this is my intent configuration, which I have deployed using Terraform. And then we can do things, if this works, like, OK, I have here a data center configuration using Cisco ACI, and I have a marketplace application. I have the security guys asking me to describe what are the security policies that we have implemented in the 3 layers of this application. Can you draw for me an ASCII diagram of not more than 20 lines, which helps me understand what these policies are? And hopefully, the AI, using this structured data, it is going to be able to generate this diagram and help me understand what the security policies are, okay? So we can see here how between the internet and the web layer, we are opening at the moment 2 ports, and then we have between the web layer and the application another set of ports and so on, right? So that's what the current configuration is. I have a developer. He's asking me to open to the internet the port 8081 because next week we are going to deploy a new application which is running on TCP port 8081. Can you edit for me the configuration, please? And in this case, the AI I am using, it is Claude. It is listening to me. It is understanding my natural language. This is a live demo. It's not a recording, as you can probably see, right? So it has edited my YAML file. This is what I need to open the port. And it is telling me, do you want to do a Terraform apply? Not yet. Another test. I want to see if you are able to help me creating a few bridge domains. So think about 10 bridge domains, which are networks in the language of ACI. Use the name of metro stations in Barcelona. And one of them should be Glorious, because this is the one closest to the place where we are. Each of these networks is going to be hosting 20 servers. So if you can calculate the size of the subnets accordingly and assign IP addresses, it will be fantastic. Thank you. And hopefully, in a few seconds, we are going to see the updated configuration. There we go.
Has it ever said no? No, I don't want to do it.
Normally it says yes. Normally it says yes. It is assigning.
Does it ever say no?
It is assigning /27, so there we have the updated configuration. And before I deploy this, look, I am new to the operations team. Before I deploy this configuration, I need your help to assess how good or bad it is. Cisco has been publishing documentation in the internet for years, so when you were trained, you probably digested a lot of Cisco ACI documentation. Can you assess this configuration and tell me from 1 to 10 how much aligned to the best practices the config is? Thank you. I am using a large language model. It's Claude. It's not a small language model. It knows about who the president of the US was, and it also knows about ACI. So in this case, it is helping me, right? Because the fact that it knows about the technology is going to be great for me. So it's telling me that I get a 7 out of 10. Maybe not good, for production. Okay? And we'll see what the recommendations are, right? So it is recommending me to enable unicast routing, limiting IP learn to subnets. It is describing what is missing, and so on, right? Normally, these configurations are a bit more complex. I try to simplify for the demo, but it gives you an idea of how now, using this tool, I could be improving the configurations. It is telling me, do you need to apply the recommended bridge domain and VRF hardening settings? Don't apply the changes now because they are looking at the watch, and I think they are going to ask me to finish soon. So I will do that later. But what I need your help with, it is the change request document. We are going to deploy this configuration on Saturday at 2 a.m. I need a change request document for my manager to approve the maintenance window. If you can describe the objective of the maintenance window, what is the configuration that we are going to deploy, what are the steps, the rollback, and by the way, this is in the data center in Sardanyola. I live in Sant Cugat, which is around 10 kilometers away. Tell me what time I should be leaving home to be on time for the maintenance window. it's going to generate a document, right? So a change request document for a network engineer is probably 1 hour of work or 2 hours of work, and this guy is going to do it in just a few seconds, maybe a couple of minutes. It is reasoning, it is processing, it is reading the configuration. So we should have it ready very soon. So you can see there it says creating file. Just to give you some context, this is Claude GitHub Copilot. It is out of the box. I didn't do any training or anything similar. It's just taking Copilot and putting it on top of the structured network configuration data. Okay. Now, this is saving a lot of time to network operations team. There are going to be cases where, like this case, where it takes time to reply. I am using internet through the mobile phone, so maybe it is getting too much time to get an answer. So let's see how it completes. Now, the other thing that you can do with this, it is to connect with external systems. And one example would be NetBox. So there we go with the document. So thanks to a tool. So let me just show you the kind of document that it is generating. Okay. So this is a markdown in this case, but it could be another format, describing the change request, what is the title for this maintenance window, my name, date of the creation, what is the risk, what is the schedule, the objective, what is the configuration to be applied, business justification. It is telling me when I should be arriving to the data center and what are the commands that I will be executing. I will be using Terraform to apply. What is the expected Terraform output, and so on, right? So it is a document, as I said, that for an engineer, it would have taken maybe a couple of hours of work. Now, model context protocol. Do we have 5 more minutes? Okay. When I start, I could spend here the full evening, believe me. Now, I want to extend the size of the web layer. I need to host 8,000 servers. Can you connect to NetBox and try to find a subnet that we can use to update the web layer configuration to allocate these 8,000 servers? Thank you. So the AI engine is going to use this model context protocol. It will go to NetBox. It will get the list of subnets. It will analyze, and it will select one of the subnets, and it will assign it to the web layer. Okay? I don't know if it went to the MCP. Did you use the model context protocol to reach NetBox? I didn't see that in the log. Please, let me know. Sometimes, no, I didn't deploy anything. I only deleted the YAML file. Now it starts to answer a bit bad. Let me see. I am asking you about where you got the subnet from. I was expecting you to use MCP server from NetBox to get the list of available subnets and then use one of them. This is AI. It's not fully deterministic. Sometimes it does things that you don't expect, okay? As you can see, maybe I did not enable the MCP server, but yeah, trust me. So what it should normally do here, it is go to NetBox, get the subnets, and select one of them from the list of available networks. Now, can you create a table summarizing the work that we have done in the last 20 minutes and compare with how much this would have taken to an engineer if he or she was doing it manually, of course? An ASCII diagram, 10 seconds. How long does it take for you to create an ASCII diagram? Probably around half an hour. Querying Netbox, which it didn't do, by the way. So 15 seconds versus 10 minutes. Generating, well, doing the assessment, like reviewing the configuration is one of the most time-consuming tasks. So let me go there for a second, right? So things like, doing the assessment, it could be 2 to 4 hours of work. Writing a document for the change request to approval, it will be maybe 1 or 2 hours. So as a summary, we have done in 3 minutes, it's not counting the time between the calls, the work that an engineer would have invested 5 to 8 hours to complete, okay? So that is the beauty of using AI for assisting operations. And the last question I have for you, to which extent the fact that we are using network as code with YAML files, with organized network configuration data, was instrumental for you to be able to complete all this work? If you can answer in 50 words and use capital letters when providing the answer, please. And we are going to finish with this, right? So let's see what it answers. But basically, structuring the network data, it is what it is enabling us to do this, work. It says that the message got lost, but normally it would answer saying yes. Using automation, it is key for AI. And the last thing, as we are closing, is can you now deploy this configuration to the network? You can do a Terraform apply so that the config will be on the network controller. Any questions, any comments? Him first.
Like it took 3 minutes to generate all of this, and now you will spend an hour just to check that it's correct, okay, and proofread all of this. So it's not comparable. So you cannot do that like this. You will never apply the production configuration using just AI. So
that is correct. What I am trying to show here, it is the art of what is possible, right? When we talk to customers about this, they say we are not ready for this. This is not how we will apply configuration in production. Typically, what we are doing it is to integrate this also with GitLab and run CI/CD pipelines and go through the whole process of following the standard procedures.
Like trained engineer will do this like in an hour, and like he will know like this is the correct way to do the things.
Mm-hmm.
So you are assuming that like people will be using the generative AI just to like assign the networks and so on and so forth. So it's a very, very simple task, okay. But more complex task, the generative AI will fail for sure, like 100%. Like
yes.
I've tried to use it, like it fails.
Yeah. There are going to be, as you said, experienced engineers, they are not going to be needing to use this, but there are going to be senior or junior guys that are going to learn from AI. And as I was describing, we are starting with AI, right? We know that a lot of the tasks that engineers do today, from calculating subnets to writing documents to getting details about the executions of a CI/CD pipeline, they are doing it manually. In the future, this will be assisted by AI. It's not going to be replaced by AI, but engineers, they are going to use AI. How they will learn? That's a good question. How they are going to learn the junior software developer when you take Cloud Code and it is developing for you the full Python scripts, right? Or code. I understand why it went out, but normally we will see the configuration. Yeah, no. It logged out. Let me see. 1 second. No, but please, if you can continue with the questions, I will answer as I am logging here. In the meantime, admin.
So, Asier, I have one question. You said that you are using a cloud-based model, so that means no rack or no specific training regarding in your case, net as code documentation. So how do you ensure that the output of the configuration is 100% accurate? And are there any alternatives or any improvements that you can do over a pre-trained model?
Yeah. You have a data model and you have a schema. So any configurations that we do, they are going to be aligned to the schema. And well, by the way, you can see here the configurations which have been deployed by Terraform, just to show you that this was real and it got deployed. Now, there is a schema which is basically dictating how the structure and what is possible and not possible in the, let me see, where is it? Here, right? So as it is generating documentation, or as it is generating configuration, the AI model, he knows the schema. It is in the folder. It has digested it. So if I try to do something which is not allowed by the schema, it will be refused. That is the first thing to know. And then, in this case, I am doing it the simple way, which is running Terraform and deploying the config. The reality, and you know this better than me, we go through CI/CD pipeline where we do pre-checks, where we deploy, we do post-checks. The demo, every deployment takes around 5 minutes. I didn't want to include it here.
And this model or this schema, you feed it to the model using prompting today, or how do you feed
prompting?
It to prompting?
Yeah. I say, where I say when you are going to generate configurations, please use the schema.yaml, and then every config it generates, it is based on this schema.
Okay.
All right. Last question.
Well, then we can make it. No, we can take it later in the coffee. I think we have 2 minutes.
Okay. So thank you, Seth, for the presentation. It was really good, and also has this hype, thing that really it's really awesome. Regarding the question about the students and the AI, we have been discussing with Chris here today, and since I'm teaching students, it's bad. Like we do give them labs. They will just copy paste the requirements. They will just hit send, copy paste, run it, then just it's bad. Even we provide screen captures, provide discussion. This is all AI generated now. So there is a big gap. I already talked with some other people from NetBCN last year about this gap, between computer scientists, which now all want to work in AI, or cybersecurity, or gaming, or fancy stuff, and then telecom engineers who want to go the other way around, we only do antennas, and then you have all this infrastructure that no one really understands. No one really, we do care about it, but the students don't. It's just yeah.
Look, and that's a great question, and I don't have an answer. And I have
so that's why I'm asking you.
My oldest son, he's at university at the UPC, and he installed already the Copilot and the Cloud Code. I say, look, this is the future. You need to learn how to use this, right? Yes. Now, today, we have junior network architects and senior network architects. Tomorrow, we will have senior network architects and AI. And in 20 years,
we'll see.
It will be a disaster, probably, because there are no junior architects becoming senior. But this applies to software development. It applies to lawyers. It applies.
Yes.
AI is being very disruptive, and I understand why you are challenging what I am presenting. I am trying just to show you the art of what is possible, the time we organize our network data. And believe, I don't know which direction this will take, but I trust the moment you can sit in your sofa and talk to the computer and build a lab, maybe not a production, but you can build a lab sitting in the sofa without touching the keyboard. That's what I was trying to
Well, I mean, the
to
point
show.
is that 100 years ago, people were saying, yeah, going to the moon maybe like in books. 40 years later, like we landed on the moon, right? So 40 years, well, yeah. So yeah, I think it's great because of that, right? It shows like the way, but also shows like the potential for disaster that we are like facing
Yes.
in terms of people not knowing how to code, not knowing how to run infrastructure.
Not knowing how to calculate a subnet, not
Exactly.
knowing many things. And as I said, I have children which are at age of university age, and that's a big concern.
Well, the thing is that
but we
even-
cannot
I have-
avoid. We
I have
cannot.
even children that are younger, and they tell me that there's people like their colleagues at fifth grade, so 10 years old, that are already using AI to do
course.
the
They
so they're not learning anything, and eventually it's like, well, I mean, once we were discussing that with Chris over lunch, like once you know the stuff, this is like a multiplying effect, but if you are not there, this
Yes.
is just like a receipt for.
It is even worse. When you look into the schemas, when you look into the Terraform modules, you know this, Christian, you have been writing Ansible modules, right? Now you take Cloud Code, it will create a plan, you define the intent, it will do the work for you. And you don't even know what is in those modules, right? Or maybe you know because you are senior, but a junior guy will develop, will play them, they will work, and thank you.
Thank you. And now we have the last presentation. We have Chris from MooseFS, distributed file system. Chris was very kind to sponsor.
Not me.
Not me. MooseFS was very kind.
Unless I don't know anything.
To sponsor our second break. So round of applause for Chris while he's preparing everything. And
Mention the Kahoot at the end.
exactly. So, and you remember the riffle? We had a problem with the algorithm. So, yeah, it's true. So Camilo, which is very, let's say, creative, he proposed to do a Kahoot. So if you know what is a Kahoot, it's like we will make some questions.
Yeah, I can do it.
Reply correctly.
For some reason it doesn't show up, I don't know why.
Yeah, you get points, and the first, I don't know, five will get a book. I think it's fair. Camilo is crafting all the questions. How many questions?
Second.
15. Okay. 15 or maybe less.
Let's try to do it via this maybe. I know that
There are
works.
the black and the white ones.
Yeah,
yes.
that should work now.
Yeah,
Now it's better, right?
All right. Thank you, Chris.
So, good evening, guys. Can you hear me? Yeah, correct. Yeah, so that was a super interesting conference, I must say. Completely different context from what I'm doing normally. So that was great to see people from other groups really having the same problems or the same ideas. I'm referring to the Christian talk about the community for network framework. I've been recently attending some guys talking about FinOps, and they are doing exactly the same. They try to bring people together to talk the same language. So all groups have different problems, but they try to come with the same type of approach, right? It was also, yes, super interesting to actually come here. So thank you so much. I don't have any slide about me, so but it's amazing for me to see that Akira, for example, we share so much experience. We live in so distant worlds, but you know, I had the same experience. I was learning to program in BASIC from the Japanese book actually, because my colleague at class had the Casio PB110, and we were doing some programming stuff like that in the Z80 assembly. Okay, going back to the topic because I have only 25 minutes. So I would like to talk a little bit more about the MooseFS Pro, but not only. This is a software solution for fault-tolerant network distributed. That's the only part that actually relates to the network stuff here. So sorry, guys, but maybe this will be also interesting to you. It's a parallel and platform independent. It's a file system and block storage solution that allows you to build distributed clusters that can store vast amount of data. As it happens, Pere is using one of the solutions in his own lab, and he was kind enough to invite me here to talk about it. So I hope that you will find at least a bit interesting what we are doing. So just a bit of a history. So the first version of the project was initiated in 2005. After 2004 publication from Google about Google file system, so company called Gemius in Poland that was doing internet research was in the need of building a software storage solution to store the data from the internet. They were not able to buy any commercial product, so they decided to implement this Google file system idea in the form of the file system. And here you have some dates, right? Right now we are in 2026, and version 5 is just about to be released with addition of the S3 protocol. Along the way, we have added some things like erasure coding, and we switched from the open source version to the pro version with some additional features. I don't want to go into much details. I just wanted to give you like a glimpse. So the product, in a sense, is for 20 years on the market. And the nice thing about it is that the cluster that we started in 2005 is still running. So it's just, updating the software, updating hardware, replacing the old one. That's the premise that we are operating under. So architecture of the product, just wanted to explain how it works. So we have a bunch of commodity hardware machines with JBots connected to local machines, and some computers that are handling the metadata of the file system. So you have fleet of machines. Disks for each of those machines is contributing to the global namespace that is presented to the clients of the system as a POSIX compliant file system. So you can run any application that requires POSIX compliant operation, which means like a hierarchical directory structure, some ownership permissions, ACLs, logs on the file system. All of that is supported by the product. And everything is connected via network, so that is something that is actually maybe a common thing for this conference. But we are not an expert in network, to be honest, right? So maybe that would be also an interesting point for us to find some collaboration and understand a little bit more what can we do to make it better. Because to be honest, we are also struggling to get the proper setup sometimes. The fastest setup that we had recently was running on 400 gigabit network with Juniper switches. And we've been almost able to saturate the network, but that's for it, right? So what are the use cases for the product? We do have customers around the world that are using it for different purposes. Like starting with the scientific data, we have some customers in US, Washington State University, Columbia is using it, for example, for genomical research, and so on. Hosting, of course, clustering, which as a basis for the Proxmox. I think also Pere is using it for the Proxmox. Supercomputing as a scratch storage, as an alternative to Ceph, but the POSIX compliant file system. For the big data analysis, like the internet research, for example, backup and archiving, the usual one, medical data storage as well. Yeah, so as I mentioned, we have customers across the board, right? So let me talk a little bit more about the reliability, the whole advantages of the solution. So, so first of all, MooseFS is a distributed storage, and it's designed for the mission critical applications. So all the features that we have built in are based around reliability. So the protocol that is governing the whole solution is really created in a way to handle failures in an automatic and self-healing type of manner. So the disk drive failure, hardware failure, all the components are actually fault tolerant, and the system is automatically detecting the failure and taking over responsibility to heal the system. So the disk failure, for example, is kicking off the replication, that the data from the failed drive is replicated from other copies in the system. High performance comes from the fact that the all data in the system is actually distributed across many components, and usually we see clusters of hundreds of servers maybe and thousands of disks connected. And then that type of a setup allows for high performance I/O operations, because the data is really spread across multiple components in the system, and the network is really the key for that to happen. We like to call that the system is actually very easy to start with. The total cost of ownership is very low at the beginning, because you can start with just the few machines and connect them via network and start growing by adding new components and not really having to buy additional licenses when it comes to the open source version. The pro version is really also very, I would say, affordable when it comes to the cost of the license compared to other solutions. And the scalability is like we've seen files in a single solutions in a single cluster with billions of files and hundreds of servers scaling up to petabytes of data, right? So customers that we currently see have like 18 to 20 to 40 petabytes of data stored on the machines. So one key aspect of the solution is that this is a hardware-independent solution. So we support different vendors. You don't have to be running machines from a very specific vendor. You can run it on any hardware that is supporting Linux operating system or POSIX compliant operating system with different drive support, spinning drives, flash drives. You can build tiers in the storage and really achieve this hardware independence. The system is scaling to hold the big data because of the number of transactions and number of files that you can store on the machines, and also the commodity hardware, right? So you don't have to have any special hardware to actually run the software. Easy administration, that's what our customers are saying to us, that the setup is really simple. Once you get the product installed on your machines, is like very minimal overhead. There is no dependencies on external libraries. The product is actually built in a way that it's self-contained. Everything is written in a low-level ANSI that is part of the system. So we don't have any external dependencies like you see in some of the products, which is, I think, quite a big advantage. The high availability option stems from the fact that all the components are really built in a way that there is no single point of failure, and the data is distributed, as I mentioned. And of course, we do have this support from the manufacturer, which is our company that we sell the solution. Yeah. So lifetime usability. So I think this is worth mentioning that MuseFS is available in two flavors. One is like an open source version that you can download from GitHub and use for free. That's where we have most of our customers coming from. And there is a version Pro that is building on top of the open source version. So you can always switch between those two versions, of course losing some of the capabilities from the Pro version into the open source version, but the protocols and the data storage are compatible. And in that way, there is no vendor locking, in a sense. And also, as I mentioned, the first cluster from 2005 is still operational. That's what we see. There is no need for every 3, 4, 5 years replacement of the hardware because of the discontinuing of the solution by the provider. Extended hardware longevity. Yeah, so features. Incremental upgrades. This is like the idea that we have behind maintaining the software, so that you can really scale down the solution by adding new hardware and replacing it with the old hardware that is not really meeting your demands on your I/O. And then the software licensing model is pretty, I would say, easy and pay as you grow. I mentioned that already. So the open source version is really like a layer below the pro version. So actually we are building it from the pro version. So there is one version of the code, and then there are some marks in the code that allows you to build this open source version from the pro version code. Lifetime license. So once you buy the license for the product, is for the lifetime, so you don't have to renew the license every year. And then low cost data safety, because we do have some in the pro version. We actually add the erasure coding that allows not only data copies but also create a storage policy that is calculating parity copies up to 8 plus 9 parity copies. Okay, so that's a redundancy. I think I talked about it a little bit. Yeah, so the self-healing capability that I wanted to spend a little bit more time on. The fact that the system is constantly monitoring all the components actually allows us to kick in those self-healing mechanisms. One aspect that I see that is very interesting is that, for example, you can get the disk failed replaced in the system within like 10 to 15 minutes, which is probably not really something that you can see in the traditional disk arrays, where you see like a rebuild process kicking in, and then the process takes really sometimes hours to complete, putting all the disk array at risk that another disk will fail during that time. And I'm sorry. And we do have this capability of on-the-fly upgrades. So you can do the upgrades to each component individually without breaking the system operation. And in that way, you can just roll upgrade the system to the latest version without stopping the operation. Okay, I don't know why it's like. So hardware independence, we already talked. Okay, so one element that is pretty, I would say, common among our customers is that it is pretty common to do the computation on nodes. So let's say you have a cluster with 10, 20, 100 nodes. What customers are typically doing is that they not only use it as a storage component, but also they can put some computational resources on the cluster, and then use that capability of the underlying hardware to do some calculations. Like, for example, in one of our customers doing video transcoding services, they have a storage, and then they do video transcoding on the same platform. The system supports different tiers of the storage based on the different disk drives, so you can define policies to migrate the data between different storages, which is really good to actually have some hot data and some cold data when working with huge big data projects. And pretty, I would say, interesting aspect of the architecture that you've seen in the beginning, that we have a master server that is handling all the metadata for the file system, is the capability of doing atomic snapshots. So it is pretty easy to create a snapshot of existing set of objects in the file system. That is an atomic operation. You can create as many snapshots as you like. Then those snapshots are actually only copy of the metadata of the file system. So any operation on any snapshot or original is kicking in the mechanism of copy and write. So it's like a minimal overhead when it comes to the I/O operations, and then there is a special command to actually remove the snapshots that you don't need. So some customers are actually using it for handling multiple experiments in the space of data exploration, and then you can easily remove those unused or failed experiments, for example. This is a very practical one, so we call it global trash, not a very good name, but that's the name sticks for years already. So it's a configurable space that you can set up on the per object level, where you define how much time the data is kept in a file system after someone will delete it. So then from the admin perspective, you can go back to the system and just restore it to the original location. That was a very practical thing when we were using this system in Gamios, because I was initially actually involved in that company at the beginning. And it saved us quite a lot of time and effort to restore the data after someone either manually or programmatically deleted the data from the file system. So parallelism is this idea behind the I/O operation handling is that the data is split across many different machines because it's split into chunks, and then I/O operations is actually communicating from the client side to many different machines at the same time. Those operations are happening at the same time, so then you get much higher performance. And the system is allowing to set up quota limits for administrators to actually limit the storage being assigned to groups, to the directories. So there are a few different layers that you can use those quota limits. And I don't know, Perry, if you are using this, but this is a really nice feature that I think is worth mentioning. Yeah, so there are some management interfaces and APIs that allow for administration of the system, and nice tools that allow integration with third-party tools. We do have some Grafana Prometheus exposure as well, so that is something that has been added in recent months. Also we are publishing some Grafana dashboards to the official Grafana repository. Yeah, we do have this support for Ethernet with different speeds. I don't think that we have included here that 400 GB link, but as I mentioned, we are not really into the network business, so that this is something that probably we'll need to investigate a little bit more. A nice thing about this topology section is that the clusters that we usually used to have were single location, but we do have some options to actually define multi-locational clusters with some links for replicating the data. So this topology section will actually allow for that configuration. And we do have some customers really running that setup with multi locations between like cities, for example, connected with the fast link. Yeah, so some stories, some customers that are using, so Gamios Poland, I mentioned that, media and entertainment market analysis, Columbia University using it for genome research project with 6 petabytes of data. Cegid is a cloud and hosting with some Git support in Sweden. In France, we do have this European Ocean Research Institute that is using it for storing some satellite images on the cluster. Cloud and hosting from Poland, they use it as a basis for just the hosting platform. In the Middle East, now pretty, I would say, hot region right now. They use it for the CDN and for storing images, ringtones, videos, and millions of files on petabyte scale. And one of the use cases that I was talking before, this IPLA is a Polish internet TV station, is connected with one of the Polish TV stations. That's where they are using MusFS as a CDN solution that is also transcoding video information. And this is also like a few petabytes of data with over, probably right now, 50 servers or whatever. So I don't know if I'm on time or not. Thank you so much. Thank you for invitation. Yep. I should have water.
Hello? Yes. I have a question. The distributed file system extremely easy to use if you have a lot of a cluster server and want to have the same content from.
Yep.
Yes. So if you have 50, it's okay. But if you have 1,000, and if all the /home
Yep.
that underneath is to be all the same with 1,000 server, it's yes. Distributed file system is the easiest because you just need to install the client app and it magically works. When I was working on the sales CPU, there was some of the sales CPU use case was HPC, a supercomputer.
Yep.
And that time I heard GPFS, ended up IBM acquiring it.
Yep.
And then the Google file system is MooseFS and then Lustre.
Yep.
Is it all?
You know,
Yes.
it's all similar, but there are some small differences. Like
Yes.
GPFS is an IBM specific, requires additional infrastructure in terms of the special card because there's like the dedicated protocol with some fiber optic connectivity, if I believe. Lustre has a little bit different structure because they actually do not provide easy way for the recovery that is distributed. They rely on the redundancy on the local nodes. So usually what you have each node in a cluster is connected to some kind of a RAID array that is actually providing them redundancy, which is causing some problems with the recovery that I was talking about. Gluster is, in my opinion, no longer maintained, is dead, right? And Ceph is a different product because in Ceph you don't have a master data. You have a Rados algorithm that is actually making it a little bit less possible to actually create something like atomic snapshots. The location of the objects on the file system is calculated based on the algorithm. In this system, there is a metadata server that, of course, it's a kind of like you might call it bottleneck, right? Because every I/O operation needs to go through the master server, not the data, but the metadata operations. But still, you know, we don't see that much of a problem, but that gives us a lot of opportunities for defining policies that are global to the file system.
Thank you very much. Yes, thank you.
Well, do you support 2+1 configuration when like two data like lakes placed in the two data center, like close to each other, and the third one just to...
Yes, we do. Yes, we do. We do via the topology and multi-location setup at the moment with the version 5.
But if the one data center like is somehow totally separated from the rest of the network, how do you like cope with this, and how you restore the data after it's already it's connected back?
Yeah, so that configuration actually requires the scenario when there is like a total separation of the network, right?
First question: How do you decide who is the master? Who storing the actual data?
Yeah. Of course,
the first question.
Yeah.
The second question: how you restore?
There is a special election mechanism that is running on the chunk servers, and all chunk servers are actually contributing to the global pool of the chunk servers, and though both locations or three locations are actually deciding on the master, right? So if there is no master selected, if there is no connection between two sides, then the one with the majority of the chunk servers will actually be selected, and then the clients.
I assume that you have the same amount of chunk servers in each data center.
Yeah, so with three configurations, with two locations connected via some link, you need to have an arbiter, right? So usually, you know, in order to have a proper setup, you need to have a third location, and there is an assumption that there is some kind of like, you know, at least one line is up, right? So if you have like complete separation, that both three and via three.
Like I'm talking about like 2+1 configuration when
Yeah,
you have two data,
Yeah.
like data centers with data, and a third data center just to like have the master node or, like, or secondary master node.
So then just the majority of the chunk servers is selected as a. It doesn't answer the question.
Like chunk servers, it's like the servers which holds the data.
Yeah, but those servers are also running the election algorithm. So on those machines, they do.
In one data center, then in another data center.
And then there is a third data center. So if those two data centers are connected, then the one that has a connection.
We have no chunk servers in the third data center. Only in
No. Okay, but the system knows about the connectivity, that there is a connectivity to the master, because it selects from two masters, one in the original data center and one in this additional that is just keeping the metadata. Yeah, so it is implemented that's actual configuration that we are recommending, right? If you have two data centers, you need to have another one just to have an arbiter to select which one is a primary one in case of the data split. I don't know if that's.
I think we are out of time
Yep.
for questions, but
we can continue the conversation.
yeah, we can continue the conversation
Yeah.
on the social part. And now I give it to Camilo
For the algorithm.
Let's see if it works. If this works.
Yeah, thank you. I should have water next time.
No worries. Thank you.
También necesito traer esto.
¿Y qué?
Necesito yo. No, pues esto es nada más la pantalla. Yo no necesito micrófono.
¿Tienes HDMI?
Lo tengo, pues, no lo tenía.
Sí, eso funciona.
Eso funciona. Okay, so just go there. This is for Christian. What are you copying? You cannot participate on your.
Why not?
Okay, if Christian wins a book, then he will do another question.
So we are gonna get the how many questions?
I think 7 questions. But
Okay. And the first 5th will.
Yeah.
So the first will choose and so on.
there are 5. Okay, so the first 5 will win. If Paolo wins the book, then he will give it to somebody else, right? Yeah. With a rough algorithm.
Yeah.
Simple to decide. This is a proof of concept, right? If there's something wrong, we just laugh about it. we don't get to pick it. Okay, we have. In case somebody is still going to join, let me know because.
One more second.
Okay, perfect. Akira is already there. You're already there. You're not Akira? Oh no, Akira is there.
Chris, you have to select the moves.
Yeah, I don't know if I can. I don't think I can.
Yeah, because I got it like.
Who is Joseph Cardona? I'm also Cardona. Yeah, the first time I'm so happy.
That's the reason that first time I met you, I thought that you were Catalan.
Yeah, because there's the town, right? But I think there are more Cardonas in Colombia than here.
Okay?
Okay, anybody?
Yes,
has-
we're waiting.
It's okay, it's okay. Sure. Maybe it's just simpler if you instead of the, well, I don't know, the code is, the QR code is fine.
Okay.
Well, it keeps coming and coming. I think we got hacked.
Yeah, that's great.
22.
Ready?
Yeah.
Everybody ready?
Yeah.
Okay. I don't even know how this will work. First time ever using it. Not here during the presentation. I don't have to clap. What keyword did we not hear today during the presentations? Digital twin. Somebody missed the digital twin. That was speaking. Big data. The big data was we hear it in the last presentation. So that was the tricky one. Christian, you will have to give it to somebody else. Okay, what was not mentioned in Akira-san's presentation? He did mention drones in the first slide, but that was tricky. Paolo, we'll have to give it to somebody else if you Okay, let's go. There are not that many questions though. What is not unused of NetLab? Sorry, what?
But it's not unused yet.
Uh-huh. Well, Ivan wanted digital twist not to be unused, but that doesn't count. Okay. Oh, Christian looks like he's going to. I'm just pressing next because. So what does ANTA do for evaluating the network?
That was your question.
There's an ANTA web page that which you can read documentation. That's how I used to get that. So, okay. Well, actually, it does use a bit of SNMP, but not much. That's what I checked. But it's not the main purpose. So you don't feel bad if you press that one. So who will train the juniors engineers in the future? It will be the big data, the MCPs, container lab. Whoever pressed that will win a book. Paolo will give it to that person. I think this is the last one. There are two more. But the junior one is the best question. This one is more serious, right? Because we do need some seriousness. So the good point is that you have to answer quickly. Because then it would be. Okay. That one had a bit of diversity. That's good. Will an encoder hallucinate? It's a more philosophical question than might be. So. I think this was the last one though, because oh no, there's another question. Maybe I got it wrong. Okay, this one is too deep. I mean, just to try to randomize things a bit. Yeah, sorry about that one. That was a bit. Okay. Very good.
Do you have the full list?
The full list of questions?
I
hope so.
Okay,
remember the first.
Yeah, we have the full list.
Okay, there we go.
Okay, so Alpo. Who is Alpo?
Christian, you want to make another thing for your
No, you will get.
Or you want the
sixth.
The sixth, perfect. Yes. Thank you. There you go.
You can choose mother. Okay, so let me actually present because this was actually given by PAC. So these two books. One is about modern network strategy. It's just a practice way to get up to speed hands-on. And this other is more traditional network automation cookbook, second edition, and it's about apps. You can choose. Which one is yours? Both. Next one.
Andrew can also choose, I guess.
Andrew can choose. Who's Andrew? Also. This one? Yes. Okay, so next ones don't have option to choose. Cristiano? Fede?
I don't have this one, but I have that one. So that's perfect.
So Johnny then? And the last one is for Xavi? could do.
Let's do that later.
Right?
Yeah, that's it.
Hey, Max, we have still like a quick coffee break just to.